And the title of this section is Simplification with Brackets or with Parentheses. Well, the nice thing is if you're adding, and you might want to make a note of this, if you are adding, and that's what we're doing right here, adding two things in brackets. Then you can just remove the brackets. Sometimes we put brackets around things to sort of hold them there. But if you're adding things together, the brackets don't actually change in order of operations. So this question here can just be 6x squared plus 5x minus 4 plus 2x squared minus 10x plus 3. Now, I rewrote it with taking the brackets off. Often students, after a couple of examples, go, I'm just not going to rewrite it. I'm just going to ignore the brackets because they're not necessary if you're adding. Now, remember when we looked to simplify this, we want to combine our like terms. So I always take the first term. I'm going to underline it, 6x squared. Are there any terms that are like terms with 6x squared? Remember, to be a like term, it has to have the same variable with the same exponents. Just like you can't add apples and oranges for math in algebra, it has to have the same variable and the same exponent. Do we have anything alike with 6x? Yes, the 2x squared. So I'm going to underline that in black. Then I'm going to go green and squiggle line. 5x. Is there anything alike with the 5x? The negative 10x. Perfect. And finally, loop-d's with the negative 4, which is a constant. Are there any other constants? The plus 3. So I'll put. So using different colors is probably the best. But if you don't have different colors to like use circles for some, squares for others, or I'm underlining them different. Now we can say, oh, these ones are alike. I have 6 of these and 2 of these. What's 6 plus 2? It's 8. So you add the black ones together, you're going to get 8x squared. Next with your green ones. Perfect, thank you very much. I have plus 5. Okay, perfect. No, I don't need that part, but this one. Okay. And with the green ones, if you think about your number line, you've got plus 5 and you're subtracting 10. You're going to end up on your number line at negative 5. And finally, the red one. If you're at minus 4 and you add 3, Logan, where would you be on your number line? Minus 1. Perfect. Well, Bobby trying to throw you off, eh? So this is simplified. We just need to combine our like terms. Even if there's brackets there and we're adding, you can just remove those brackets. But if you're subtracting, then the brackets become important. Because what happens is you're subtracting everything in the brackets. If you like to highlight things in your notes, this would be something that would be useful to highlight. Okay? Change all the signs in the second polynomial. It has a special name for that. When you change all the signs, it's called the additive inverse. I'm not going to ask you that definition, though. But if you're subtracting, you have to change all the signs in the second one. Then you can remove the brackets. So the first one, 7x squared minus 4x plus 1, notice I removed the brackets, kept that one the same. But the second one, every single thing changed signs. So instead of 5x squared, minus 5x squared. Instead of plus 5x, minus 5x. And instead of a minus 2, a plus 2. One of the things sometimes people do to show that they remember to change all the signs is they say, I want this minus to go to this one, this minus to go to this one, and this minus sign to go to that one. Well, a minus times a positive makes that negative. A minus times a positive makes that one negative. And a minus times a negative makes the last one positive. So, once the brackets are removed, it's back to, do we have like terms? I'll underline the first one with x squared. We have another one here, negative 5x squared. Perfect. Next one in green. Squiggle line underneath it, minus 4x. Do we have anything alike with the minus 4x? The minus 5x. And finally, the loop-de-loos with the plus 1. The plus 2. So now we can go back and look at our black ones. I have 7x squared minus 5x squared. 7 minus 5? 2x squared. I've got a minus 4x and a minus 5x. Think of your number line. If you're at minus 4 and you subtract 5. Careful. Negative 9. And finally, the red ones, you're at plus 1, plus 2, plus 3. Excellent, excellent. Okay, so try this one on your own. I'll give you 30 seconds head start. Okay, let's do a check. You see the minus out in the sign? That means this minus is going to go to each one of these. We start off by rewriting the first one. And then minus a negative, that will make that one plus. Minus a positive, that one will switch to negative. Minus a negative, that one will switch to positive. Starting with 4a, are there anything alike with the 4a? There's another 4a. 5c. Minus 3c. Any other ones? No, those are different. There's 3 of them that are alike with the c's. And then the 3b, there's only one, so that's nothing you can do with that. So adding the 4a and the 4a on your number line, that would give you 8 a's. To the green ones, plus 5c, minus 3, minus 1, would give you plus 1 in the end. And then you still have plus 3b to finish off. We can rewrite the first one without the brackets. 3m squared minus 5m plus 8n. Then this negative is going to change all of these ones. So it's going to be negative 4m squared. Then this will be plus 3m, and then it'll be subtract 5n. Are there any alike with 3m squared? There's a 4m squared. Perfect. Are there any alike? Minus 5m to plus 3m. And are there any alike? So now that you've identified which ones are alike, if you're at 3m squared and you subtract 4 on your number line, 3 minus 4? Negative 1. Minus 5 plus 3? Negative 2. And finally, you're at 8 and you subtract 5. You're at 3. So, right? There's an equal sign here, so we have the answer. Okay? Again, whenever we're doing like terms, we would start by underlining like terms. Is there anything with a 4x squared? I mean, not with a 4. There is a question mark x squared there. And we need it to equal this in the end. With the negative 3x, we have a question mark there, and it has to equal negative 9. And then with the number, there's a number there, there's a number of mystery there, it has to be 6. So let's look at this black one first. You need 4 plus something to equal 1. Negative 3. In other words, you'd have to subtract 3. Let's go to the green one. You need minus 3 plus something to equal minus 9. On fire. You're not allowed to answer the last one. 2 plus something has to be 8. Yes. Okay, we're going to do one more. Okay. In the English language, for setting this one up, what does the word from mean? If you take 5 from 8.
Sorry for the interruption.
Hello?
I can get Logan to come to the office at the bell, please, for a
If you take 5 apples from 8 apples, does it make sense that the map is 8 minus 5? Even though you said it backwards. So if we subtract this from this, in the math, we would say, I have this amount. Yeah, 3 left is right. And I'm going to subtract this amount. And when we subtract something, that would go to each of those. So we would get 8x squared minus 9x minus 8, subtract 3x squared plus 5x minus 2. Do we have any like terms with the 8x squared? Yes. Do we have any like terms with the negative 9x? And then finally, minus 8 and the negative 2. So if we put 8 minus 3, Carly, what would we get? Five. Perfect. And if we have negative 9 on our number line and we add 5, Duncan, where would we end up? We're negative 9 and you add 5. Okay, think about your number line. You're starting at negative 9 and you're going 5 to the right. Close. Negative 4. Right? And then finally, you've got the minus 8 and you subtract 2 more. Caden, where would you end up on your number line? You're at negative 8 and you subtract 2. Nope. Think about your number line. You're starting at negative 8 and subtracting means you're going back further. Right? Here's my number line. I'll draw it out for you. Here's 0. You'd go all the way to negative 8 and then you'd go 2 more. Negative 10. Perfect. Perfect.